Alright, welcome. This is the Week 8 Outcome 1 video on chemical reactions. And so I'm going to be doing some different things on this. I have a Prezi, but then I'm also going to be showing you some simulations of the various concepts. Alright, so let's go ahead and jump off here. Here are the key points for today's talk. Okay, we're going to be talking that chemical reactions is just about rearranging the chemical bonds or forming new bonds. Okay, energy affects matter and chemical reactions, and so we'll talk about how that affects it and why it's important. Okay, all chemical reactions have what's called an activation energy, and you need that you need to be at a certain activation energy to get the reaction to occur. Okay, and then chemical reactions can absorb or give off energy. Okay, and we'll talk about that. Look at some graphs that demonstrates that. Alright, and then we want to look and predict the results of some chemical reactions. We're going to go over 3 reactions that are common in biology, and those are the ones you should know for the future. Alright, so let's go ahead and jump in. Now, chemical reactions just rearrange the atoms. Okay, so I have 3 different examples here. Alright, so we have kind of an additive model. Okay, so we have A and B, and we are producing them to make AB. Now, the little arrow in a chemical reaction, that means yields, okay, or makes. Okay, so you can always say that A and B yields AB. Okay, example 2, this is a rearrangement or a swapping. Okay, so we have AB plus CD, and that yields AD and BC. Okay, example 3, we have A, B, which are bonded, and we're breaking them apart and making A and B. Okay, so really when we're making chemical reactions, we're just doing probably one of these 3 to a different scale. Now, some chemical reactions can be more complex than others, but really it kind of comes down to this rearrangement of atoms. Okay, so energy and matter, okay, they cannot be created or destroyed, only changed. So energy can be changed, so like for example sunlight, light energy can be turned into heat, and you feel that when you stand out in the sun. That light energy is hitting your skin and it's warming you up. Okay? And matter cannot be created or destroyed, only changed. So we have 3 forms of matter. We have the solid form, liquid, and gas form. And energy has different, it affects those substances differently. Okay, so when you increase the energy, or you heat an atom, you make it move faster. Conversely, when you decrease the energy or cool those atoms, it makes them move more slowly. So let me just show you a demonstration of that. Okay, so here's a simulation model where I have neon in this jar. As you can see, it's at 35 degrees Kelvin, and these molecules are moving fairly slowly. So if I heat this up, okay, what you're going to notice is the molecules start moving faster and faster. Let's go ahead and take it up to 50. Okay, so those molecules are moving substantially faster. Okay, and you can see they're kind of knocking into each other with more force. Okay, let's cool that back down. And you'll see they start moving slower and slower. Those collisions become less violent. Okay, there we go, until they kind of the molecules stop moving all together and they just start this jiggling here. Okay, so that'd be a solid. Okay, so energy has this effect on matter, either making it move faster or slower. Now, why is that important? Okay, that's important because of the activation energy, okay, of a chemical reaction. And this really depends on what's called collision theory. Collision theory is this idea that the atoms actually have to kind of hit each other for the chemical reaction to take place. The reaction can't take place if they're not touching. Okay. Now, also, not only do they have to touch, but they have to collide with such a force that you can actually make the bonding occur. Okay. So that minimum amount of force required, that's called the activation energy. Okay, so let's see another demonstration of that. Okay, so let's just demonstrate that you need a certain velocity. Okay, so in this reaction here we have substance A and BC, and we're going to change it to AB plus C. Okay, so let's look at this. If I give it just a little bit of energy here, okay, you can see that that reaction did not take place. Okay, the molecules did not hit with substantial force. Okay, let's reset this, and we'll give this more energy. All right, there you go. And now you can see that the particles are colliding with enough force to actually make the reaction occur. Okay, let's look at this a different way and the effect of heat on this. Okay, so let's put some A molecules in here. So we'll pump some of those in, and then we'll put some BC molecules in here. Okay, now, as these things are moving around right now, okay, they're bouncing around, they're colliding with each other, but the reaction is not taking place. Okay, and that's because we have not yet reached that activation energy, the top of that peak, where the reaction will occur spontaneously. Okay, so let's go ahead and raise the temperature here. As we raise the temperature, we raise the energy, we have the particles move faster and faster, and there you go. Now you can see that the reaction is actually starting to take place. Okay. Okay, because we reached that activation energy. Okay, so that's the idea. Okay, activation energy is the amount of motion necessary for the atoms to collide with sufficient force to make the reaction occur. Alright, now, once you get the reaction to occur, that reaction can have one of two different outcomes. It can be either endothermic or exothermic. Okay, if the reaction gives off more energy than its activation energy, okay, so if you were to carry out this experiment and you put your hands on the jar and it's warm afterwards, it's giving off extra energy, that's called exothermic. Okay, exo meaning out, it's giving off energy, okay, in the form of heat. Okay, now, conversely, if the reaction gives off less energy than its activation energy, so you have to put energy into it and you don't get any energy back out, okay, that's called endothermic. Okay, endo meaning in. Sorry, that's a typo. Endo meaning inside or going in. Okay, so you should know the difference between an exothermic reaction and an endothermic reaction. Okay, and you should also be able to graph that in an assignment. Alright, so let's look at some different chemical reactions. There are three that I'd like you to know. The first is the oxidation reaction. Okay, this is where you're using oxygen to break apart some substance into carbon dioxide and water. Okay, so this right here is breaking down, this is cellular respiration, breaking down sugar, okay, and releasing energy. Okay, but also like combustion, when you burn wood in a stove, that's an oxidative reaction. Okay, you're giving off carbon dioxide and water. The internal combustion engine in your car does this. It's burning the gasoline. It's oxidizing the gasoline. Okay, so it's a very, very common reaction. The next one is the dehydration reaction. Okay, and what you're doing in a dehydration reaction is you are adding molecules together. So here we have a small molecule with two. We're adding this third one. And when we do that, we're putting it on, but we're actually getting out a molecule of water. We're taking out a molecule of water. That's dehydration. Okay, and you can attach monomers this way through a dehydration reaction. The opposite of that reaction is called a hydration reaction, where you're adding water back in to break a bond. Okay, so if you're going to break down a polymer chain in its monomers, you'd be doing a hydration reaction. You'd be putting in water. Okay. So, the other thing about this, a dehydration reaction requires a net input of energy, so it's endothermic. A dehydration reaction gives off energy, making it exothermic. Okay, oxidation reactions are almost always exothermic. Okay, you get off energy from that. All right, so that's the talk for this week. Just to go back over, we talked about how chemical reactions are just a rearranging of the chemical bonds. We looked at how energy affects matter. Okay, and chemical reactions, so it increases or decreases the velocity of the molecules or atoms. Activation energy is the minimum amount of energy you have to have in the system to have that reaction occur. Okay, we talked about endothermic and exothermic reactions. Endothermic reactions are ones that you have to put in more energy than you get out. Exothermic reactions where you get out more energy than you put in. Okay, and then we talked about the three different types of chemical reactions that you'll see most often in this class. Okay, as always, if you have any additional questions about this, you can hit me up in class, and I hope that was helpful. Thank you very much.